Okay, so this unit has been around what factors impact the solubility of a solute. So the first thing we talked about was the nature of the solute solvent. So something will be soluble if they are the same. So if they're both polar, they will dissolve, they will be soluble. If they're both non-polar, they will be soluble. The second factor is what you guys just worked on graphing, is temperature. So your graph that you created should have looked something like this. You only had 4 lines, obviously. So you had temperature, you had the amount that would dissolve in 100 grams of water, and you had the different curves. Some of them rapidly increase how much you can dissolve as temperature increases. Some of them, something like NH3, actually becomes less soluble. That's because ammonia is a gas. Some of them are very, very soluble, and some of them are not so soluble. And then something like salt, NaCl, it doesn't make a huge difference what the temperature is. But overall, the general trend from looking at the graph we can see is that as temperature increases, solubility increases. So as temperature increases, solubility increases. And this is going to be true except for gases. We'll talk about those later. Okay, gases actually become less soluble. If you think about what keeps bubbles in your soda, it's when it's colder, when you keep your soda cold. So as temperature increases, solubility increases except for gases. And some examples, if you think hot tea versus iced tea, trying to dissolve sugar, it's going to be a lot easier to dissolve in the hot tea. Okay, and then as far as the gases, what I just said, bubbles stay in your soda when it's cold. Okay, so that's why we have the exception of the rule. All right, so this is reference table G in your reference tables. Okay, so basically what the curves are showing, if we're on that line, then that's going to be when something is saturated. So it's holding as much as it possibly can. So for example, at, if we say 40 degrees, and I come up here, I can dissolve 105 grams of NaNO3 in 40 degree 100 grams of water. That will make it saturated, meaning it's dissolved as much as it can. If I pick a point and it falls under the line, then that's called unsaturated. So for example, if at 40 degrees, I only dissolve 90 grams, I haven't dissolved as much as I can. I'm below the line, I'm under the line. I could dissolve 105, I only dissolved 90. So that would be considered unsaturated. And then if I'm over the line, there's a weird phenomena called supersaturated. And that means that I've actually dissolved more than I can. This is like how you make rock candy or hard candy. You heat it up really high, you can dissolve a lot of sugar, and then as soon as it cools, it starts to crystallize. So that would be if at 40 degrees, I didn't just dissolve 105, I heated it up and dissolved more than I was supposed to, so maybe 120. And as soon as the temperature cools, it's going to drop right out. All right, so let's look at a sample question. Solution of NaNO3, so that means we're talking about this line here, contains 1 gram of solute dissolved in 100 grams of water. At 50 degrees, this solution is, so we've got 1 gram in 100 grams of water. All right, so 50 degrees, if I go all the way up to NaO3, I can actually dissolve 150